In this video, we'll be talking about indices. In mathematics, oftentimes you run into numbers that are written in the form a to the power of n. Now, when you see such numbers, the a, which is a number to which another number is being raised, is called the base. So this is called the base. And the n, the power to which a is raised, is called the index. Hence indices, because indices is the plural of index, or the exponent, or the power. So oftentimes we read this as a raised to the power of n. Now, what this literally means is that a, if you see this, a raised to the power 2, what we're saying is a times a. A raised to the power 5 is equal to a times a times a times a times a 5 times. Now, what if we say 3 raised to the power 2? This is equal to 3 times 3, which is equal to 9. Now, if we say a raised to the power n equals a times a times a times a up until the nth a. Now, if we say 8 times 6, in the same vein, what we mean is 8 times 8 times 8 times 8 times 8 times 8, times 8, and that is going to be equal to 262,144. Now, if you're wondering how you can compute this faster on your calculator, you would see a button which carries the symbol x to the power of y. So to compute 8 raised to the power 6, all you need to do is press 8, press the button x to the power of y, and press the button 6. So 8, press the button x to the power of y, press the button 6, and you should have this answer. Now, this is what we mean when we say 8 to the power of 6 or a number to the power of another number. But in this, we wouldn't always have it straightforward this way. And so there are certain laws which are related to indices that we must know. So that takes us to the laws of indices. And we're going to be looking at 8 laws in total. We'll also try and prove the laws as clearly as we can in this video. So the very first one we'll be looking at, the first law, is a raised to the power m multiplied by a raised to the power n is equal to a m plus n. So if you have the same basis or the same base raised to the power a number multiplied by the same base raised to the power another number, you can solve that easily by adding both powers. And if we take an example, if we say a raised to the power 3 multiplied by a raised to the power 2. Now what we have, a raised to the power 3 is a times a times a. Now if we multiply this by a raised to the power 2, which is a times a, what we have is 1, 2, 3, 4, 5 eventually. And so this is equal to a raised to the power 5. So this stands to reason that we could as well have just solved it from the beginning using the rule, which is a raised to the power 3 times a raised to the power 2 is equal to a raised to the power 3 plus 2, which would have been equal to a raised to the power 5. So this is equal to this. That proves the law. The second law we'll be looking at is am divided by an is equal to am minus n. And so if we use an example just like we did with the previous one, which is a raised to the power 5 divided by a raised to power 2. So a raised to power 5 is a times a times a times a times a. And a raised to power 2 divided by a raised to power 2, which is a times a. This cancels out this cancels out this, and we're left with 1, 2, 3. We're left with a raised to power 3. So this goes without saying that a raised to power 5 minus a raised to power 2 is equal to a raised to power 5 minus 2, which is also equal to a 3. This equals this, and that proves that. So the third law we'll be looking at is the law that says that if you have a raised to power m raised to power n, and this will be equal to am multiplied by n. So if we have an example, a raised to power 3 or raised to power 2. So this is a raised to power 3, or a cubed, as we'll say, squared. So a cubed is a times a times a. Now if we square this, that means we're multiplying it by itself, a times a times a. If you write this expression out as a whole, what you have is a times a times a multiplied by a times a times a. And that's going to be 1, 2, 3, 4, 5, 6 equal to a raised to power 6. And so if we write out this law, if we solve this using this law, that will be a cubed squared equals a3 times 2, which is equal to a6. So this is equal to this, and that's proven. So that's the third law. A raised to power m or raised to power n is equal to a raised to power m multiplied by n. So the fourth law we'll be talking about says that a raised to power minus n is equal to 1 over a raised to power n. So if we take an example such as a squared divided by a raised to power 6. Now what this is saying is that a times a, which is a squared, divided by a raised to power 6, a times a times a times a times a times a. So a cancels out a, this cancels out this, and we're left with 1, 2, 3, 4, a over a raised to power 4. 1 over a raised to power 4. Now, we remember the second law. The second law says that am divided by an equals am minus n. So if we use this second law to solve this, what we would have is a squared divided by a raised to power 6. This will be equal to a squared minus a raised to power 2 minus 6, and this will be equal to a raised to power minus 4. And so this goes without saying that this is equal to this. So that is a raised to power minus 4 is equal to 1 over a raised to power 4. And this is what the law says. A raised to power minus n is equal to 1 over a raised to power n. Proven. The fifth law we'll be looking at says a raised to power 0 is equal to 1. So if we look at an example which is a raised to power 3 divided by a raised to power 3. If we write this out explicitly, what we're saying is a times a times a divided by a times a times a. And needless to say that all these cancel out, and we would have 1. Now, if we solve this using rule 2 again, law 2 says AM divided by AN is equal to AM minus N. So that's A raised to power 3 divided by A raised to power 3 equals A raised to power 3 minus 3, which is equal to A raised to power 0. So this is equal to this. And what we're saying is A raised to power 0 is equal to 1. In the same vein, 2 raised to power 0 is equal to 1. 1000 raised to power 0 equals 1. 1 million raised to power 0 equals 1. Infinity raised to power 0 equals 1. Anything you raise to the power of 0 equals 1. Anything, A represents anything in this case. Whatever it is you raise to the power of 0 would be equal to 1. The sixth law we'll be looking at says A raised to power 1 over N is equal to the nth root of A. If we have A squared, A raised to power half, and we multiply that by A raised to power half, if we use the first law, which says that A raised to power M multiplied by A raised to power N equals AM plus N. Now, if we use that law to solve this, what we would have is that A half plus half equals A. Now, in the same vein, we know that the square root of A multiplied by the square root of A equals the square root of A squared, and square times the square root cancels out, so we have A. So what we're saying essentially is that this expression is equal to this expression because the both results in A. And if that is the case, then what we're saying is that A raised to power half is equal to the square root of A. And that's exactly what the law is saying. The law is saying that if you raise A to 1 over N, what you have is the nth root of A. So we're raising A here to the half, to the power of half, which is 1 over 2. And that's equal to the square root of A. So if we raise A to the power of 1 over 3, what we're saying is that this is going to be equal to the cube root of A. Raise A to the power of 1 over 7. What we have is 7 over A. And so 1A raised to power N is equal to the nth root of A. Now, if we also have A raised to power M over N, what if this is not 1, but this is M instead? If you remember the third law says that A raised to power M all raised to power N is equal to AMN. So if we split this up, what we would actually have is A raised to power M multiplied by 1N, because M multiplied by 1 over N will result in M over N. And so if we use the law now, what we would have is that this is equal to the nth root of AM. So AM over N is actually equal to the nth root of A raised to power M. The seventh law we'll be looking at is AB raised to power N is equal to A raised to power N, b raised to power n. And to prove that, if we have an example such as ab raised to power 3, what we're essentially saying is ab multiplied by ab multiplied by ab. And this is no doubt saying a times a times a and b times b times b. And simply said, all this forms a cubed and this forms b cubed, which is equal to a. And so that proves the law that ab raised to power n is equal to a raised to power n, b raised to power n. And the last law we'll be looking at is that a over b raised to power n is equal to an over bn. If we use another example like the previous one, which is a over b cubed, that's going to be a over b times a over b times a over b. And what we're saying in essence is a times a, which is a cubed, over b times b, which is b cubed. So a over b cubed is equal to a cubed over b cubed. So those are the laws of indices. So if we do a quick summary of all the laws here, the first one says that if we have a raised to power m multiplied by a raised to power n, that equals a raised to power m plus n. The second law says if we have a raised to power m divided by a raised to power n, that equals a raised to power m minus n. The third law says if we have a raised to power m all raised to power n, then we have a raised to power m n. The fourth law says if we have a raised to power minus n, then that is equal to 1 over a raised to power n. The fifth law says a raised to power 0 is equal to 1. The sixth law says that a raised to power 1 over n equals the nth root of a. And there's an extra in that which says that a raised to power m over n is equal to the nth root of a raised to power m. The seventh law says that if you have a b raised to power n, then this is equal to a raised to power n b raised to power n. And the eighth law says that if we have a over b all raised to power n, then we have a raised to power n over b raised to power n. So we have our summary of laws here, and I'm not sure they're too difficult to get into one's head, but it would be nice that we do some problems, we solve some problems to be conversant with the usage and application of these laws, not just to know them, but to also be able to apply them. And so we go into exercises. So the first question we'll be solving is 4 squared multiplied by 4 raised to power minus 3. Now I'll write the rules that we'll be applying on the right side here so that it doesn't interfere with our solving of the problem. So for this particular case, we'll be using the first rule, which says that a raised to power m multiplied by a raised to power n is equal to amn. And so 4 raised to the power 2 plus minus 3, and that is equal to 4 2 minus 3, which is equal to 4 raised to the power minus 1. 2 minus 3 equals minus 1. And we also know that a law, I think it's the fourth law, says that a raised to the power minus n is equal to 1 over a raised to the power n. So in this case, 4 raised to the power minus 1 is equal to 1 over 4. 4 raised to the power 1, but we don't need to write the 1, so 1 over 4. And so 4 squared times 4 minus 3 is equal to 1 over 4. The second question we'll be solving is x raised to the power 5, x raised to the power 8. For this particular one, we'll be using the first law, which says that a raised to the power m multiplied by a raised to the power n is equal to a raised to the power m plus n. So in this case, x 5 plus 8, and that is equal to x raised to the power 13. The third question we'll be solving is y raised to the power 4 all raised to the power 6. And I'm sure we remember the third law, which says that a raised to the power m all raised to the power n is equal to a m multiplied by n. So in this case, this is going to be equal to y4 multiplied by 6, which is equal to y raised to the power 24. So the next question we'll be solving is 3 squared 2 squared raised to the power minus 2 over 2 raised to the power 3. So the first part I want to focus on is this part. And for this part, we'll be using the law that says that a raised to the power m raised to the power n is equal to a m multiplied by n. And so this is going to become 3 squared 2 multiplied by minus 2 is going to be equal to 2 raised to the power minus 4 and 2 raised to the power 3. So the next thing we'll do is focus on these two, and we'll be using the law that says that am divided by a raised to the power n is equal to a raised to the power m minus n. So in this case, we have that 2 raised to the power minus 4 divided by 2 raised to the power 3 is equal to 2 minus 4 minus 3, and that is equal to 2 minus 7. So if we bring that into this equation, what this will result to is equal to 3 squared 2 raised to the power minus 7. And essentially what 2 raised to the power minus 7 means is equal to, remember the rule that says that a raised to the power minus n is equal to 1 over a raised to the power n. So 2 raised to the power minus 7. So 2 raised to the power minus 7 is equal to 1 over 2 raised to the power 7. So that means that what we have here is actually 3 squared over 2 raised to the power 7. And that is equal to 3 squared is 9. And 2 raised to the power 7 is equal to 128. So this boils down to this, 128. And 9 over 128. The next question is 3 raised to the power m multiplied by 27 raised to the power m multiplied by 9 raised to the power minus m. Now as it stands, because we have different bases, it looks like the law cannot be applied here. But if you look closely, you would notice that we can express 27 and 9 as a base of 3 raised to the power of something. So if we do that, we have that 3 raised to power m is equal to, multiplied by 27 equals 3 raised to power 3. 3 cubed is actually 27, so 3 cubed raised to power m multiplied by 9 is 3 squared raised to power minus m. So if we simplify this further, we'll use the law that says that a raised to power m raised to power n is equal to am multiplied by n. We'll use that for both of this. And so this becomes 3m multiplied by 3 times m is 3 raised to power 3m multiplied by 2 times minus m is minus 2m, 3 raised to power minus 2m. And then to solve everything, we would use the rule that says that a raised to power m multiplied by a raised to power n is equal to a raised to power m plus n. So since we have common bases for all three, we have 3 equals m plus 3m plus minus 2m, which is this. And so that will result into 3m plus 3m, 3 raised to power m plus 3m minus 2m. But because we know that plus times minus is equal to minus. And so m plus 3m minus 2m equals, m plus 3m is 4m minus 2m is 2m. So 3 raised to power 2m. And that's our final answer. Just so that I don't gloss over this, in case this is foreign to you, you should know that plus times plus is equal to plus. Plus times minus is equal to minus. Minus times plus is equal to minus. And minus times minus becomes plus. So whenever you have the same signs multiplying each other, you get a positive. Positive times plus is equal to plus. Minus times minus is equal to plus. But whenever you have different signs multiplying each other, you always have a negative. So that's that. And we'll be using these same things in following questions as well. The next question says minus 2ab squared over 2b. Simplify this. Now, if we use the rule that says that ab raised to power n is equal to a raised to power n b raised to power n, then we can expand the numerator here, which is going to be equal to minus 2 squared a squared b squared all over 2b. Now this is going to be equal to minus 2 squared is minus 2 times minus 2. And we just said that minus 2 times minus 2. And we just said our negative times negative results in a positive. So 2 times 2 is 4. And that's equal to positive 4. So that's 4 a squared b squared over 2b. B cancels out 1b here, because we know that b squared over b is equal to b2 minus 1, which is equal to b, and 2 cancels 4 to give 2. So our final answer is 2a squared b. The next question is 4 over 25 all raised to power 3 over 2. Simplify. So we'll be using the rule that says that a raised to power m over n is equal to the nth root of a raised to the power m. So in this case, what we have is this is going to be equal to the square root of 4 over 25 cubed. So n is equal to 2, m is equal to 3, and this is the nth root is the square root in this case because we have 2, the square root of 4 over 5, which is our a, raised to the power m. And if we explicitly solve this, we have that the square root of 4 cubed over 25 cubed. And that, of course, we get from the rule that says that a over b raised to the power n is equal to a raised to the power n over b raised to the power n. And that's how we get this. And this is going to be equal to 4 cubed is 64. 4 times 4 times 4, 64. And 25 cubed, 25 times 25 times 25 is equal to 15,625. Now, if you find the square root of this, the square root of 64 is 8. And the square root of this is 25, is 125. So our final answer is 8 over 125. The next question says 8 raised to the power 243,458 plus 121 raised to the power 437 all raised to the power 0. Now this obviously in the brackets is going to be a difficult thing to solve, but let's assume that this even adds up to 1 billion whatever, and you raise it up to the power of 0. A rule, we remember the rule that says that a raised to the power 0 is equal to 1. So anything raised to the power 0, it doesn't matter what it is in this bracket. Let's just say this is equal to this. It doesn't matter, as long as we are raising it up to the power of 0, this is equal to 1. And that's our final answer. Next question is 15 raised to the power 0 plus 15 raised to the power 1 over 2. Now, as we just said, anything raised to the power 0 is equal to 1. So this obviously will be 15 raised to the power 0 becomes 1 plus 15 all raised to the power 1 over 2. So 1 plus 15 is equal to 16 raised to the power 1 over 2. Now we know that a raised to the power 1 over n is equal to the nth root of a. So obviously this is going to be equal to the square root of 16, and that is equal to 4. The next question is 3 squared raised to the power minus half multiplied by 9 raised to the power 4 raised to the power minus 1 all divided by 27 raised to the power minus 3. Again, what we would need to do to apply the law of indices here is to make sure that all the bases are common, and to do that we can express 9 as a base 3 and we can express 27 in terms of 3 as well. So this is going to be equal to 3 squared raised to the power minus half. 9 is equal to 3 squared as well, raised to the power 4 raised to the power minus 1. So that's 9 becomes 3 squared raised to the power 4 and raised to the power minus 1. And 27 is 3 cubed raised to the power minus 3. And so in this case, we would apply the law that says that a raised to the power m raised to the power n is equal to a raised to the power m times n. And so this expression becomes 2 times minus half, 2 multiplied by minus 1 over 2 equals, this 2 cancels out this 2 to give 1. 1 multiplied by minus 1 is equal to minus 1. So this becomes 3 raised to the power minus 1. 2 times 4 is 8. 8 times minus 1 is minus 8. So this becomes 3 raised to the power minus 8. And 3 times minus 3 is minus 9. And so that's equal to 3 raised to the power minus 9. So if we solve the numerator parts, which we can do using the law a raised to the power m multiplied by a raised to the power n equals a m plus n, and that is equal to 3 minus 1 plus minus 8 over 3 raised to the power minus 9. Minus 1 minus, this becomes 3 minus 1 minus 8 over 3 raised to the power minus 9. And that's minus 1 minus 8 is equal to minus 9. So 3 raised to the power minus 9 over 3 raised to the power minus 9. Without any further complication, we can tell that these two are equal, so they will be equal to 1. And our final answer is 1. So the next question we'll be solving requires that we prove that the square root of c squared d raised to the power 6 over the square root of 4c cubed d raised to the power minus 4 is equal to d raised to the power 5 over the square root of 4c. So we're supposed to start from this expression and see if we can use the laws of indices to derive this expression. So if we start from this, we'll have that the square root of c squared d raised to the power 6 over the square root of 4c cubed d raised to the power minus 4. Now, from this law, from the law that says that a raised to the power 1 over n is equal to the nth root of a, we know that when we have a square root of something, that is equal to that thing, which is, in this case, is c squared d raised to the power 6, all raised to the power of half. And the same thing goes for the denominator, which is 4c cubed d raised to the power minus 4, all raised to the power half. And we also remember the law that says that a b raised to the power n is equal to a raised to the power n b raised to the power n. So if we do that by expanding this and raising these individual components in the brackets to the power of half, what we have is that c squared raised to the power half is 2 multiplied by half, and that's going to result in c raised to the power 1. I think I should just write it out so that we avoid any confusion. So the first one here is going to be c squared raised to the power half, and then d raised to the power 6 also raised to the power half, and we'll have 4 raised to the power half, c cubed all raised to the power half, and d raised to the power minus 4 also raised to the power half. And this is going to be 2 times, here we remember the rule that says that a raised to the power m all raised to the power n is equal to a raised to the power m times n. So that's the next rule we'll apply here. So c squared all raised to power half is going to be 2 multiplied by half. And 2 cancels out 2. So we have c raised to power 1. That's it. And 6 multiplied by half is going to be 2 cancels out 6 to give 3. That's going to be multiplied by d cubed. And would have 4 raised to power half. We could reduce this, but we see that 4 still exists in our final value. So I would advise that we leave that now, since we don't have to get rid of it. And 6 raised to power 6 cubed multiplied by half is going to be half of 3, and that's going to be c 3 over 2. And minus 4 multiplied by half is going to be d raised to power minus 2. So we'll have to solve for c and d separately, because those are the common bases that we have. And to evaluate those, what we would use is the law that says that a raised to power m divided by a raised to power n is equal to a raised to power m minus n. So if we bring down our 4 raised to power half, because that's not going to be affected, we have 1 over 4 raised to power half. And then we can solve for c and d differently, because those are the common bases that we have. So if we bring out c divided by c raised to power 3 over 2, and that's going to be equal to c1 minus 3 over 2. And 1 minus 3 over 2 results in c raised to power minus half. And so we have c raised to power minus half. And then we also solve for d, which is d cubed, which is this, divided by d raised to power minus 2. And that's going to be equal to d3 minus minus 2. Now minus times minus is plus, so we have d3 raised to power 3 plus 2. And that results in d raised to power 5. So we have d raised to power 5. And if we write this explicitly, what we're saying is, we know this c raised to power minus half from the law that says that, okay, let me get rid of this so that we can have space. From the law that says that a raised to power minus n is equal to 1 over a raised to power n, we know that c raised to power minus half is equal to 1 over c raised to power half. So this is going to become d raised to power 5 over 4 raised to power half c raised to power half. And obviously this is going to be d raised to power 5 over 4c raised to power half. And we know, so this is going to be d raised to power 5. And we know that anything raised to power half is the square root of that. So that's going to be square root of 4c. So d raised to power 5 over square root of 4c is exactly the expression that we were required to look for here. And that proves this. I hope we've been able to learn all that is required in the laws of indices in this video. In the next video, we'll be looking at standard forms. And in the next video after that, we'll be looking at the laws of logarithm. See you then. Bye. Thank you.